Welcome to, and that should say Unit 8 up there, but of course it doesn't. Let me fix that real quick. So Unit 8 is going to be indirect measurement. So your learning targets, be able to accurately draw and solve problems involving indirect measurement. Pretty short for vocabulary: mirror method, shadow method, and indirect measurement. So those are the things we're going to be talking about today. So we're putting into place kind of the real-life application of similar triangles. So indirect measurement, and usually we do talk about height, but it doesn't have to be height. It's basically just a way to measure without directly measuring. So if you think about things like maybe the water tower in Newville, I guess you can climb up there, but maybe we don't want to. A big tree or something, things that we can't measure directly. Okay? So we're going to have two ways to do this. The first way, and there's actually more than two ways, but we're going to specifically talk about two ways, is the shadow method. So if we think about standing outside, we have an object, let's say a flagpole we want to know the height of. We can measure its shadow along the ground. We can also measure our shadow, okay, and our height. We should know our height. Now when we think about, the sun's kind of like up here. I know I'm a wonderful drawer. The sun's kind of up there. The angle here is going to be the same as the angle here. And it might be like a 0.0000000 degree one difference, but they're the same. And they both have right angles. So the triangles are similar by angle. So for the shadow method, all we do is we want to know the height of the flagpole. We know the height that we are. We know the shadow of the flagpole. So the flagpole's on top on both sides. Okay, and we know our shadow. So just like we did before, we can cross multiply. We can divide. And we can get our answer, which I believe is 20. Okay. Sometimes it's written more like the one on the bottom. So if we want to know the height of the tree, the height of the person is 5.5. We know the shadow of the tree. I believe that means, and this is kind of hard to tell sometimes, if that goes to the person or to here. I'm going to kind of assume that goes to here. So the height of the tree is actually going to be 21 because of the 15 plus 6 over the height of the person. So we cross multiply. Okay, 6 times x is just 6x. 21 times 5.5 is 115.5. We divide, and we would get, so the height of the tree would be 19.25 feet. Now when we look at the problems, we're going to have to use words because they're going to be word problems. Now the mirror method is a little bit different. So this right here is where the mirror would be. So what you do is you kind of place a mirror between where you are and the object, and you step back until you can see the object in the middle of the mirror. And the angle that you're looking down at is going to be the same as the angle that's bounced back up to the top of the object. So you kind of want the very top of the object to be in the middle of the mirror. But to solve this, I'm looking for the height of the tree. I know the height of the person. Okay, now I think here this whole thing, let's say this whole thing is 16. And again, hopefully it'll be a little bit more obvious in some of the problems. So that means this would be 12, 16 minus 4. So the distance from the object to the mirror is 12. The distance from the person to the mirror is 4. So we would cross multiply. 4x equals, and I believe that would be 66. Okay, so then I would divide by 4 on both sides and get x equals 16.5. So the height of the tree would be 16.5, and those are all in feet. So we'll look at some examples here. So in the diagram below, a large flagpole stands outside of an office building. Marquise realizes that when he looks up from the ground 60 meters away from the flagpole, the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall and Marquise is 170 meters from the building, how tall is the building? So again, these angles right here would have to be the same, and these are both right angles. So the triangles are similar by angle. So that would be the answer to part A. Now, all of these questions kind of deal with the same thing. We're not necessarily going to put it in terms of scale factors or similar figures or ratios. We're just kind of going to solve. Okay, so you won't see all of these questions in all of the problems. So I want to know the height of the building. That's h in this case. I know the distance, the ground distance of the shadow is 170 meters. I know that the flagpole is 35 meters tall, and I know the distance, the shadow of that is 60 meters. So I can cross multiply. I would get 60h equals 35 times 170, 5,950. Okay, I would divide by 60, and I would get h equals 99.2, and it was in meters. So it's a word problem, so I should say the height of the building is 99.2 meters. And I would be done. Okay, let's look at another example here. Katerina's boat has come untied and floated away from the lake. She is standing atop a cliff. Actually, I'm going to save this one for you guys. I want to do one that deals more with shadows. So you guys can do that. Maybe we'll come back to that. So let's do this one where you have to actually draw a picture. So we have a fire hydrant. I'm just going to use red here because fire hydrants are red. 3 feet tall, cast a shadow that's 4 feet. At the same time over here, we have a pole that casts a shadow that's 28 feet. So I want to know how tall that pole is. So I'm looking for the height of the pole. I know the height of the fire hydrant. I know the shadow of the pole, so the pole's staying on top, and the shadow of the fire hydrant staying on bottom, the shadow of the fire hydrant. So I cross multiply. So 4x, 3 times 28 is 84. I divide by 4, I get x equals 21, which means the height of the pole is 21 feet. Okay. So here's an example about how deep the water is. So assuming it's going down at the same rate, so we know that 3 meters into the water, it's 5 meters deep. So if we want to know how far, if we go 62 meters in, how deep it is. So D is the whole way out. That's the depth of the ocean the whole way out. That's going to correspond to the 5 in the smaller triangle. It's 62 meters the whole way out, and 5 meters, when it was 5 meters deep, it was 3 meters out. So I would cross multiply. I would get 3D equals, I think that would be 310. Divide by 3. I would get D equals, that would be 103.3. And I'm rounding to 1 decimal meters. So the water is 103.3 meters deep. Okay. Let's see. Which other one do we want to do here? I'll go ahead and do this one. Get to see me. So we have a Ferris wheel here. I don't know if anybody's ever been to Cedar Point. We got a lot of good roller coasters. The giant wheel at Cedar Point in Ohio is one of the tallest Ferris wheels in the country at 136 feet tall. So it's 136 feet. If the giant wheel casts a shadow that's 34 feet, write and solve a proportion to show the height of a nearby man who cast a 1.5 foot shadow. So I'm going to make that 1.5, and we're looking for the height of this man. Again, because the sun is shining down at the same angles, we have similar triangles. So I would do x, which is the height of the man, over the height of the, I guess, giant wheel, Ferris wheel. And then I would do the shadow of the man over the shadow of the Ferris wheel. So when I cross multiply here, I get 3.4x equals 204. If I divide by 3.4, divide by 3.4, I get x equals 60. So apparently, the man is, oh, see what I messed up there? That wasn't 3.4. That was 34, wasn't it? I put 3.4. So let's try this again. So 204 divided by 34. See, sometimes answers don't make sense. So you got to go back and think about them. Having a 60-foot man doesn't really make sense. So I got 6 feet now. So the man is 6 foot tall. I think that makes a little more sense in context of the problem. So be careful with that. Now I'll also say, be careful with mixed measurements sometimes. So if something's in inches, something's in feet, you have to convert them all to the same measurement before you solve. So make sure everything is the same unit before you go to solve. So as always, if you have any questions, come in person, email, find some other resources if you need to. But now you get to practice the rest of these problems, and hopefully you understand what you're doing. Have a great day.